Next assembly we're going to be discussing from Watts is the 719 series, which is a double check assembly, and the corresponding 919, which is a reduced pressure principle assembly. Like all manufacturers, they have that model number, and then they have little numbers and digits afterwards that do mean something important when we're talking about the repair parts of these assemblies. The R designations have to do with the designation of the sizes. In other words, they were using R designations when they were using an oversized body, like a 1-inch, and they would call it a 719 R10 for the 1/2 and 3/4, yet it would be at parts of a 1-inch body. Even though it was a 1/2 and 3/4 inch piping assembly, they used a 1-inch body with bushings because they didn't have production done on the smaller bodies or approvals on the smaller bodies yet. Here's a picture of the double check, the 719. It is a poppet style check, both checks coming up from the top. The covers screw into the body as opposed to bolted in design. Bronze body construction, test cucks pointing up from the top. Here's the check body with the check assembly out in an exploded view. Seat O-ring seat, disc retainer bolt disc, disc holder, check spring, O-ring, and check cover. Same check mechanisms as we see in the 719 series as we're going to see in the 919 RP series. Again, produced in sizes 1/2 through 2 inch. Here's what the 919 looked like in sizes 1/2 through 2 inch against bronze body construction. Check covers on the top, screwed into the body. Relief valve cover is mounted by 3 bolts on the bottom. And relief valve cover, you've got to rotate to remove it. We'll talk about that when we disassemble it. Here's the exploded view of the parts. Same check mechanisms as we saw in the 719 series. Relief valve stem assembly, we have our relief valve seat O-ring, relief valve seat, relief spring, disc retainer, the rolling diaphragm, the rolling diaphragm, the retainer, O-ring for the cover, and the relief valve cover. So that's the 719 double check, the 919 reduced pressure principle assembly. Let's take them apart and see what they look like. Let's do the 719 and 919 series now. I have the 719 double check here. We'll take that one apart first. Excuse me. Check covers unscrew from the top. There will be slight spring tension as the cover comes off. O-ring cover, O-ring. Check spring, check disc holder, and check seat comes out in one piece just like this. O-ring on the seat. One screw holds the disc into the disc holder. And notice the shape of the spring. It's a barrel-shaped spring, which has some interesting properties we'll talk about in a second, and a bushing inside the cover just like this. So why the shape of the spring? Well, one of the problems with a spring when it compresses, that compression shape like that, was getting that tilting action back and forth. By having this in a smaller ring in the upper and lower portion, it was concentrating the load of the spring at the center of that disc, which happens to be the exact spot where the spring sits on the seat. So in essence, the seat is the same place as the center of that spring. Anyway, so rebuilding it, just to replace the parts. Reassemble is going to be just the reverse. Seat in, O-ring, disc with disc holder, spring, make sure it's lined up in the center. Make sure your bushing is good for the upper part of the stem is there and not damaged. As you tighten this cover in, you want to be very careful. Make sure you don't feel any galling or moving of that spring as you tighten that. In other words, if that spring catches on there, you could twist inside the barrel of that check assembly. So just feel it as you tighten it, make sure it's going in there. That's the check mechanisms on the 719. So here's a cutaway of the 919 reduced pressure principle assembly. Same check mechanisms we saw in the 719. Checks mounted, cover pointing up from the top. Covers unscrewed just like we saw the 719 check, so we won't take those apart. Let's take a look at the relief valve, which is underneath here. Relief valve discharge here and relief valve cover. And there'll be 3 relief valve cover bolts. When you remove the cover bolts, there will not be spring tension from the relief valve spring underneath. And in fact, the stem won't come out at all. What you have to do is rotate it just small, about 1/8 of a turn, and the stem will come out in one piece. Relief valve spring. Relief valve seat is screwed into the body and stays in the body for the average repair. The stem travels along the cover. You'll notice that there's an O-ring on the cover. You'll also notice that there's an air breather in the end of that relief valve cover. So what happens is that stem travels back and forth like this, and as it travels back and forth, the air in that stem strokes back and forth like this. High pressure on this side, low pressure on this side of our relief valve sensing line comes through here and through the recesses in the cover, and that's how the stem moves back and forth. Disassembly, there's going to be one screw that holds the relief valve disc into the disc holder, which is also one of the two rolling diaphragm retainers. Relief valve disc comes out. To separate the two halves of the stem, they unscrew, one threads into the other, female and male thread. Rolling diaphragm, and there's the pieces. So reassembly is going to be just the reverse. Diaphragm. This has to be very tight because we have to facilitate a water seal across that rolling diaphragm. We don't have the assistance of an O-ring in this case. Replace our stem O-ring, our cover O-ring. Put our relief valve disc back into the stem like this. Stem, make sure the O-rings are placed on the stem and properly lubricated. Cover O-ring properly replaced. Inspect our relief valve seat, which we don't have to replace for the average repair. Relief valve stem. Now, again, the cover goes in and has to have that same little rotation to get it into the recess like that, and then rotates over to line up the 3 bolt holes. Once you line up the 3 bolt holes, then your cover bolts can go back in, just like that. And that's the model 919 RP. These are also sold under the Ames name. The 200B is the same as the 719, which is the double check. The 400B is the same as the 919 RP. Because remember, Ames was purchased, or Watts purchased the Ames company, and they were marketing different models and different assemblies. And this was an assembly that was developed under the Watts name, but was sold under both Watts and Ames name. So the Watts model number 719, 919 designation, the Ames designation 200B and 400B. Either one, repair parts are exactly the same, and models are just the same. It's just a private label agreement between the two companies. Next assembly we're going to discuss is the Watts model 757 and 757A models of double check assemblies, and the model 957 and 957 reduced pressure principal backflow prevention assemblies. These assemblies were sold by Watts, and actually they were produced under the company called Hunter, and were sold under that name from about 2000 to about 2002. In 2002, Watts bought the Hunter model and their designs and marketed them under the Ames name. They had bought Ames earlier, and this was a product that kind of fit some of their existing product lines, and they sold them under the Ames name of the C200 or C200A. They also had an M200, M200A, which were similar in construction but not exactly the same as the 757 and the 757A double checks. We're not going to take these apart in the Watts name because we took these apart under the Ames section, which you can review these designs in the Ames section, but I want to show you what it is. It's a stainless steel body, and what was unique about it is that it had a sleeve, and the sleeve here had to slide over to the right and allow access of the checks to come out up from the top. The end dimensions of the body were not flanged but had a grooved coupling, and by putting a grooved gate valve or an elbow like you see here on the end, had some unusual piping configurations up and down, horizontal, and rotating in different orientations for applications of installation criteria. Here's a cutaway showing the side of that check assembly. Here's the open. They use a torsion spring design. Once you slid this cover over the top, the checks came out from the top, first and second check. Check came out. A pin was needed to hold the check assemblies in a contained fashion, and then the check assembly could be disassembled for the repair, changing the check disc inside there. That's the 757 design of double check. The 957, again, 2.5 through 10 inch, same check body, relief valve mounted underneath, relief valve sensing line external. Same sleeve design where the sleeve had to be pushed over to the side. It was important that there was no paint or debris on that because there was 2 O-rings that sat in the sleeve, and as you pushed the sleeve over, you could damage those O-rings inside. There was a small little clip on the top which allowed to get you access so that you get enough leverage to move that sleeve over to the right and get access to the checks. The relief valve assembly on the bottom, unscrewed from the bottom, was held on the bottom by an O-ring. The 957 check assemblies, same as we saw in the 757, relief valve underneath. Here's a cutaway showing the side of the checks in the wide open position and relief valve mounted under there. We're not going to take this apart in the Watts name. We did this completely apart disassemble it and put it back together under the Ames name. So if you want to go back and see it under the Colt 200 series for the double check, the Colt 300 for the double check detector assembly, the Colt 400, C400 for the RP, and the C500 or Colt 500 for the reduced pressure detector assembly. Same as the 757 and the 957 series of backflow assemblies under Watts name. Next assembly we're going to discuss from Watts is the 770 series and 772, which is a subset of the 770. These are double check assemblies. Production started early 90s, around 93-ish, up to about into the 90s, about 98, 97-ish. Double check assembly. They made a double check detector assembly version, model 770 DCDA and 772 DCDA. They also have a corresponding reduced pressure assembly, which utilizes the similar check assemblies, and that's the model 990s and 992s. And we'll talk about those also. Let's talk basically about what the 770 construction is. It's a check body made of ductile iron, fused epoxy coated. They use a check mechanism that, not a poppet, not a swing type check, but it's an unusual kind of check that requires a spring load to be released to replace a vulcanized clapper plate as opposed to a flat check rubber disc. And we'll show that when we take it apart. Here's a picture of what the 770 looked like. Again, body fused epoxy coated, but covers come off from the top, single axis to each check for each check body. But you can just see on the bottom of that check there's two little bolts that are underneath there that have to be removed to take the check assembly apart. And they have to come apart in a certain order because of the spring load inside it. 772 utilizes the same parts as the 770. What was different about the two designations, 772 and when we get to the RP, the 992 version, was that they took the assemblies, and what they did, as you can see here in this picture, that the gate valve had two different flange sizes. In other words, a 10-inch 772 had a 10-inch outlet flange here, but on the body size, inlet flange, but on the outlet flange where it was attached to the check body was one size less, so it was like an 8-inch. So this would be an 8-inch 770 with this 8 by 10 gate valve. Now this whole thing was a 10-inch 772. So when you have the two designation in the model, what it meant is that you had a gate valve that had two different flanges. One different size on the inlet, which was larger. The outlet flange, which was attached to the check body on the first check here, was smaller. Corresponding same gate valve on the outlet. In other words, attached to the check body here would be an 8-inch, but on the outlet would be a 10-inch, which attached to the piping system. So this way they had a 4, 6, and 8-inch model 770, but by having different gate valves with the flanges, they were able to come up with different sizing configurations going all the way up to 10-inch. The 770 DCDA version, here's the main valve and the bypass piped around it, so they did make a double check detector assembly version of the 770, 772 series. Here's a close-up of the check view. As I said, there's two bolts on the bottom that held the check chassis mechanism inside the body. They utilized a spring assembly, which you see here, and instead of a flat rubber disc, it was a vulcanized clapper plate. So this chassis mechanism was mounted from the bottom of the assembly. This spring assembly was pushed in between the clips that you see on the back end of that chassis, and that's how the spring load was given on the check assembly. So you had to have a lever, and the lever would go inside the body like this, move the spring back, release the spring tension, and then you could go ahead and remove the check assembly out for the repair. And we'll go through that. Check seats required a special tool to be replaced. The seats were just pressed into the body but were sealed by an O-ring. The reduced pressure assembly versions, the 990 and 992, exactly the same as 772. So the 990 had the 4, 6, and 8-inch with the standard gate valve. The 992 had the gate valve that had two different sizes on the inlet and outlet flange so that it could opt different sizes. Relief valve was mounted underneath the check body, as you see here, with an external relief valve sensing line. The relief valve, as I said, was attached by a nipple underneath the check assembly. External relief valve sensing line. Here's an exploded view of that relief valve stem. So 770, 772, difference between them was the gate valves. In other words, the internal parts were the same, but by having different gate valves on them, if it was a straight flange to flange, it could be a 770 double check or a 990 RP. If they had the two side flanges where one was larger than the other, then it could be the 772 double check or 992 RP assembly. They did make a double check detector assembly in the 770 and 772 DCDA, and they made a reduced pressure detector assembly in the 990 and 992 RPDA. So that's the mechanisms of the check of the relief valve, Check mechanisms are the same as in the 770. So let's go ahead and take it apart and see what the 770 and 992s look like inside. Here's a check valve from the 770-990 series. Here's the relief valve, which mounts underneath the check body here. External relief valve sensing line, which goes from the body to the relief valve. So for the average repair, the relief valve body does not have to be removed from the body. You just can take the cover off. We'll talk about the relief valves in a minute. Let's do the check assemblies first. Single access for each check. This is just a single check, obviously. The second check would be bolted next to it. So once we got the water shut off, pressurized, remove our cover bolts. Cover's going to come off like this. Cover O-ring seals the O-ring, but I want you to look inside this body to see what we're looking at, because this is going to be kind of interesting what we're seeing. What we're seeing inside here is a spring. That's a spring assembly, and it's attached in two spots, one here and one over here. So we have to compress the spring. In other words, we have to squeeze it and pull it out through the body. It's held in by two clips, one clip right here and the second clip right back over here. So to properly disengage the spring, you're going to need a large screwdriver, something like this. You're going to want to get it in here underneath the spring like that. See if I can do it so you can see. Pull backwards, and once you squeeze that out of that holder, the spring assembly will come out in one piece just like that. So you have to squeeze the end of the spring inward like that, pulling it up, and it comes out in one piece. Okay, now we go to the bottom of the check body, and what you'll see are two bolts underneath. Once the spring tension is released, it releases the load on that check, and now we have to remove that chassis assembly that you see right in here from the body, and the way that's done is the two bolts on the bottom. Do not touch these two bolts until you've removed the spring tension. So spring tension must be removed first, bolts are removed second. Now once you start removing these bolts, you want to hang on to that chassis mechanism, because you can see if you just drop the two bolts, it's just going to fall in and it may damage the seat inside there. So remove the two bolts, hanging on to the chassis mechanism. The bolts have an O-ring gasket, an O-ring seal on the bottom, which seals to the body. Makes sense since the bolt goes right through the body. Hanging on to that chassis mechanism, now you can bring it out from the top once the bolts are out. And then the check seat, which is right there, is pressed into the body. Needs a special tool to take it in or take it out, sealed by an O-ring on the back side. Average repair, it does not have to be taken apart. And it's going to look just like that. So now here's what it looks like outside the body. In other words, the two bolts would be mounted from the bottom through the body. This is pressing against the seat. The spring mechanism sits just like that. So that's what you would be seeing if the body wasn't around. What you have to do to show you what I showed you in the video is get a screwdriver, push inward and up, and the spring will come out just like that. Once the spring comes out in one piece, now you take the two bolts off, chassis comes out in one piece. Now, again, we're using a vulcanized clapper plate, not a flat rubber disc. And so to change this vulcanized clapper plate, we have a little Allen head screw right here. We remove that Allen head screw, drive the pin out, take the clapper plate out. The repair kit contains a new clapper plate. Put the clapper plate back in, put our spacer back here, and then retighten our Allen head wrench Allen head bolt right there. So that's, you're going to need the Allen head wrench to remove that in order to get the clapper plate out for reassembly. Once we replaced our clapper plate, we're ready to go back in, inspected our seat, make sure it's working good. I mean, it's not damaged. Again, same reverse process. We've got to put the clapper plate in, being careful not to damage the seat inside there. Going to insert our bolts in from the bottom. Catch it into that chassis mechanism. As I mentioned, 1, 2. It's important that you get that in before you try putting the spring in. Get those in place. Now, just put the bolts in hand tight for now, like that. And before I tighten down on them, I want to do one more thing. I want to come in here and make sure the alignment of that disc is in the center of the seat. By placing my hand in there, I'm going to make sure that the disc is centered to the seat. In other words, I can move that quite a bit right now because those bolts are still a little loose. So by centering the disc to the seat, making sure it's dead center, now I can go ahead and take my ratchet and tighten down on these two bolts on the bottom. But only once I know that it's centered right there. So once I have that in and tightened, now I've got to put my spring assembly back in. And so the spring assembly, which looks like this, has two sides. There's a pin sticking up to one side and a rounded side here. The rounded side is what pushes against that check disc. So as the disc moves, it rotates across that roller right here. So what we do is we put the rear, which has the pin on it, on the back side on the two clips, just like that. Okay? Now, once that's in place, we have to, once that's in place, now we have to push it to the top and compress it downwards. I'll try to do it on the side if I can. Pushing down. And it'll pop into place just like that. Once you have it in place, you can see the load on the spring, make sure the spring is straight. Sometimes a little twisting of that spring is helpful to make sure that it's not been twisted through its travel. Making sure the spring is pushing perfectly straight, just like that, is critical to the function of that design. If the spring is hipped to one side like that, it's not going to have the full load on its travel. So the spring has to be perfectly straight. Once we've got the check assembly loaded, cover O-ring goes on the body. Check cover on top. Go ahead and get our cover bolts. And as I mentioned, this is the same check mechanism in the 770, 772, 990, 992. To reiterate that difference between the ones with the 2 designation, again, the outlet flange and of the gate valve will be different than the inlet flange. Where on the 770, 990 series, it's just a standard flange by flange gate valve where both flanges are the same size. But to accommodate different sizes, like I showed you in the pictures, the 2 designations have a larger outlet flange on the gate valve. And that's what the check valves look like on our 770, 992 series. The RP version, the 990s and 992s, the relief valve is mounted by a brass nipple underneath, as you can see here. So I want to remove this for our little demonstration, but the average repair, you would not unscrew this off of the body. All you do is take the cover out just like this. Relief valve sensing line would be external, would be attached right here, and attached to the check body just like that. So for the normal repair, we're just going to remove the cover. Cover is going to come off in one piece like that. Stem assembly will come out just like that. Our relief valve seat stays inside the relief valve body. Does not have to be replaced for the average repair. It's stainless steel, as you can see there. The stem assembly is very similar to what we see in the 909 2-inch design. So the relief valve stem, one nut on the back side, diaphragm upper plate, diaphragm, our relief valve disc, our stem O-ring, and our diaphragm retainer. That's what, for the normal repair, what you'd be replacing is just that diaphragm and relief valve disc. Reassembly is going to be the reverse. Now, this plate is a different diameter than the bolt. It's not meant to be the diameter of that, it's meant to be the diameter of this nut. It sits on the back side just like that. There's a sharp and a rounded edge. The rounded edge must go against the diaphragm. Get it onto the nut, put it in place on the stem, and it has to be in the center, just like that. Tighten that down. The back side of the stem does not have to be removed for the average repair. This is our relief valve spring right here. Unscrew that bolt, you'll release the spring tension. If for some reason you do replace that relief valve spring, be very careful because there's a small O-ring in the center of this piston right here on the inside, on the stem. The outer O-ring is the important one, acts as a guide for the relief valve as it travels in and out. Make sure it's properly lubricated because it will not work properly if it's not, and the lubricant comes with the repair kit. Reassembly is going to be reinserting the stem, proper lubricated O-ring, inside relief valve stem, slowly pushing that in. Now, lining up the relief valve stem, looking through the relief valve discharge is important because we want to make sure it moves easily in and out. So, moving it back and forth, make sure I have movement. Reattaching your relief valve cover. Now, you want to be careful because the cover has our relief valve hose high pressure sensing line. Make sure it lines up back in line with the hose so you can reconnect it. It doesn't do any good if all of a sudden you put it back together and then the hose doesn't reach the cover. Line up your bolt holes in the diaphragm like this. Make sure you can move the relief valve stem in with the cover. Go ahead and tighten your bolts, and that's how we're going to rebuild the relief valve of the 9992. So 770 and 990 checks, as we saw here. 2 bolts on the bottom, chassis mechanism inside. The RP has the relief valve underneath, uses an external relief valve sensing line. That's the 770, 990 series of Watts backflow assemblies.